So we're still in section 4J. We're still talking about solving simultaneous equations, but now we're going to talk about the third and final method for solving them. Remember, we've already looked at solving them by graphing. If you have the graph, then you simply read the point where the two lines intersect. Yeah? But if that veers off of one of those intersection points, that's really hard to do. And besides, you don't want to have to graph every one of these you see to be able to do that. Last time, we looked at substitution. And substitution is a great method as long as one of them is y equals or the other is x equals. If you start having to move stuff around, it's more work. And secondly, you can get into fractions, decimals, make sign errors, etc. There are lots of places where you can make a mistake. So today what we're going to do is we're going to look at the third and final method, and that is elimination. Now, if you're going to eliminate something, that means you're going to do what with it? Get rid of it, right? So we're just going to get rid of it. Okay? And in mathematics, if we want to get rid of something, we do the opposite. So to get rid of a positive 2, I would minus 2 or subtract 2, right? Okay. You can even do it with division. You're not going to have it. To get rid of a times b, if I wanted to move the a, the opposite of multiply is divide. So all you're going to do to eliminate something is you're going to use the opposite. Now that's fine if you already have opposites, but most of the time we need to create opposites in order to make this work. So let's go through and think about and talk about the steps for making this work. This first step in solving by elimination is you need to first set up the equation. You may still have to do a little bit of work. So you may have to do a little bit of work setting up the equation. And here's what it should look like. You should have your x term plus or minus a y term should equal a number term. And then the same thing in the second equation. Now, the x and the y could be reversed. You could have your y's first and then your x's. That doesn't matter. But what you should be seeing about this setup is that all of the like terms are lined up one over the other. So x terms on top of x terms, y terms on top of y terms, number terms on top of number terms, and traditionally we put the number terms after the equal symbol. Okay? Most of the time it's going to be lined up for you, because it is a simultaneous set of simultaneous equations, but if you have to move things around, now at least you know how to set it up, right? You just want like terms on top of like terms. In order to eliminate, we must have opposites. What that means is exactly the same term, but different signs. So you have to have opposites. So exactly the same term, but different signs. So for example, what's the opposite of a positive 5x? Negative 5x, good. What's the opposite of negative 9y? Positive 9y. What's the opposite of negative y? Positive y. So that as long as they're identical, except for the sign, then they're opposites, okay? The opposite of negative x is not positive 2x, right? They have to be exactly the same term. Now, sometimes you'll get lucky and you'll have opposites, but most of the time, you may have to change signs, which is perfectly fine. You can change the signs of an equation as much as you want to. But if I change one sign in an equation, then what? I've got to change them all. Yeah. All right? So if you change one sign, you have to change them all. Perfectly fine. You may have to multiply to get a different coefficient. Remember that coefficient means the number in front of the letter? So you may have to multiply to get a different coefficient. So for example, if I had negative y and positive 4y, the signs are opposites, yeah? But 4 and 1, which is the number in front of that if there is no number, 4 and 1 are not opposites. But I could simply multiply that by 4, and now I have opposites. So you may have to change the sign, you may have to change the coefficient or the number in front. Sometimes you may have to change both. Okay? And you may have to do this for one or both equations. Occasionally, you'll have to multiply both equations by something in order to get opposites. So say, for example, we had positive 3x and negative 5x. Can I turn a 3 into a 5? Nope. Can I turn a 5 into a 3? Nope. But I can turn them both into a 15, right? So I'd multiply the top one by 5 and the bottom one by 3, which gives me 15x and negative 15x. And those two things are now opposites. So once you have opposites, if you added them together, you would get 0, which would mean you have no more of those terms. And that's our next step. We're going to add the equations together. Which will eliminate one of the variable terms. So just simply add them together. Now the book will tell you that you can either add them or subtract them. But if you take the time to get opposites, then it's always going to be add. Then you'll be safer if you have just one process always. Right? You'll know that if you have opposites, then you always simply need to add them together. If you don't have opposites, if you have two terms that have exactly the same, that are exactly the same, you could subtract them, which would make them opposites. But I think it's usually easier just to change all the signs and then just add the two equations together. If you no longer have two equations but just one, then you can solve them. Because we'll have either eliminated the x's or the y's, so now we have an equation we can solve. And now we get right back to what we did last time. Substitute that value into one of the original equations and then solve to find the other value. So substitution is still a part of this, but you won't be doing any substitution until after you use the elimination to solve to find one of them. Bless you. All right? Okay. All right. So there's an example where we already had everything lined up. We already had opposites. So we just solved for our x, then substituted back to find our y, which gave us our answer.